Hello, my name is Steve Bowler, and in this video we're going to be taking a look at OSPF. Specifically within OSPF, we're going to be taking a look at the different area types, such as stub, not so stubby area, totally stubby area, not so stubby, totally stubby. A lot of this can sound confusing and very strange at first, but when you break down the area types and you actually see the LSA filtering that OSPF is doing with the different types of areas, then it becomes a little more easier to approach and to take a look at. So what I'm going to show you in this lab is the area types, and what we're going to do, as you can see here, we're going to go ahead and configure all these routers. We have 5 routers for this lab. We have router 10 and router 1 are both in area 10. They're going to have their fast Ethernet link in area 10. Router 1 and 2 are going to be in area 0, so they're going to be the backbone. Over here we have router 2 and router 3, and they are both going to be part of area 23. And what I'm going to do too is I'm going to run RIP version 2 on router 3 and router 4, and then I'm going to redistribute the RIP routes into OSPF, and then we're going to be performing a special type of area type, which is known as the not so stubby area. So we're going to take a look at all these different area types. We're going to break them down, make them understandable and approachable, so that you can get a better understanding of how they work and exactly what type of OSPF LSAs we will be filtering and why we are trying to filter them. So again, most of the reason why we're doing LSA filtering with the area types is we're just we're trying to relax the burden of the OSPF updates and the Link State database and the CPU on the router. So we're just trying to get rid of LSA types that don't need to be flooded into the OSPF area. So let's go ahead and get it busy here. Let's go ahead and get into router 10. I guess we'll go into first here. We'll go ahead and configure this from scratch. So I've been meaning to do this lab for a long time. I've had a lot of requests for people to do this, and I'm just now getting into it. I've been pretty busy studying everything, but I'm trying to make some time in the day and in the week to do a couple labs. So what we're going to do is go under interface fast unit 00. Again, in this OSPF lab, we're just using broadcast links here. So we're just going to keep the media type pretty simple. The network type, it's just going to be broadcast multi-access. So we're not going to be doing anything tricky here. With like non-broadcast, multi-access, and all that kind of stuff. We're just going to be running broadcast here. So under interface fastnet 00, we're going to give the IP address is going to be 172.16.10.10. Go ahead and do a no shut here, and what we'll do, we'll go ahead and enable OSPF on the router. We'll just do router OSPF 1. Again, 1 is the process ID, and we'll go ahead and specify our network here, which is 172.16.10.10. So we're specifically going to run OSPF on this IP address, or on the interface which has this IP address, which is in this case fast Ethernet 00. And we're going to run this again, is going to be in area 10. Remember, router 1 and 10 are in area 10 here. So we have router 10. done here, we're going to go to router 1. We're going to see that faster than at 01 is connected to router 10. So we're going to go ahead and router 1. And we're going to go ahead and start this guy up. Again, interface faster than at 01. We'll do that first. Give it the IP address 172.16.10.1. Do a no shut. Then we'll go ahead and configure the interface towards router 2. It's going to be IP address 172.16.12.1/24 is what we'll use for all our subnets in this lab to keep it pretty simple here. We'll do a no shut here as well. Then we will go into router 1. Let's go ahead and create loopback zeros on all these routers. So router 1 is going to be 1.1.1.1/32. And then we're going to go under router OSPF 1. And we're going to give the router ID here. So we're going to manually process the router ID, or input it, so that we won't allow OSPF to pick the router ID. We're going to put it in here, so that way, it doesn't become a physical interface, and then if that physical interface drops, then it'll drop, reachability. It could break, our OSPF domain. So we're just going to manually put it, hard code the router ID as the IP address of the loopback interface. That way there's no questions asked on to what the router ID is. And then we're going to run OSPF on our networks here, 172.16.10.1, which is the link to router 10, and give that a host mask. And then we're going to actually not host mask, actually we're going to put this into area 10 here. So we'll put 10, and we should see the neighbor come up. As you can see, our OSPF adjacency change is now done. So we have a neighbor now to router 10. We'll look at that in a second. Our next network statement is going to be 172.16.12.1, and this is going to be 0.0.0.0 to area in area 0. So this is our link to router 2 here. Okay, so now that that is done, let's go ahead and go to router 2, get router 2 set up. We'll give our interface loopback 0. It's going to be IP address, it's going to be 2.2.2.2, and we'll give it a host mask here of all /32 there. Then we'll go under on router 2, let's see, on router 2, the fast Ethernet 0 is connected to router 1, so we'll go to router 2, and we said interface FA0. 0 is connected to router 1, so we'll give it the IP address 172.16, what is it, 12.2/24, and we'll do a no shut here. Then we'll go interface FA01, which is the connection to router 3. We'll give it the IP address 172.16.23.2. and we'll put that in /24, and we'll do a no shut here. Then we'll go under OSPF process 1, router OSPF 1, and we'll do the network statement 172.16 12.2, and then 0.0.0.0 area 0 to put it into area 0 along with router 1 here. And our next statement is going to be network 172.16.23.2 0.0.0.0, and that's going to be an area 23, and that's going to partner with and be our router that's in area 23 with router 3. And let's see, did I specify the router ID? Not sure if I did. Let's just go back here real fast. Router ID is 2.2.2.2 on router 2. Okay, so router 2 is complete so far. The best part is yet to come here. We still haven't done any LSA filtering yet with our area types. We're going to get to that here in a second. We're just building the lab real fast so that we can get comfortable with, you know, our networks and our areas here. Router 3, we're going to no, host name is not router 2, it's router 3. What we'll do here is interface loopback 0. We're going to here give it the IP address of 3.3.3.3/32. And on router 3, let's go and see. On router 3, FA00 is connected to router 2. So on router 3, if we go interface FA00, give it the IP address of 172.16.23.3 since it connects to router 2. Put it in the same subnet here. We'll do a no shut. We'll go under interface FA01 and we'll give it the IP address of 172.16.34.3, and this is going to appear with router 4. However, we're not going to run OSPF on that interface specifically on that network. We're going to be running RIP from router 3 to router 4 in the 34 network. So we'll go ahead and do a no shut on that interface. Then we'll go under router OSPF 1. And then we'll specify our router ID, which is our loopback 0 interface, which is all 3s on router 3. And then we'll go ahead and do a network statement 172.16.23.3 and put this interface FA00 into area 23. And as you can see here, we now have our adjacency up from router 3 to router 2. And that should be it there. We're not going to do any more filtering. I'm sorry, not filtering. We're not going to do any more network, assigning into the OSPF domain. For now, at least. Router 3. Let's see. Let me go back to router. Let me go back to router 1 here. Forgot to set the router ID on router 10. Go interface loopback 0. Then IP address is going to be, we'll just give it 10.10.10.10. Then router OSPF 1, and then router ID 10.10.10.10. So it's just a best practice to, to get your router ID set correctly. We don't want to have any possibility that the OSPF router ID could become a physical active interface on the router. Because if that interface drops, you're pretty much, you pretty much will lose your whole OSPF network or a part of it. So now that we have all the routers configured except for router 4, let's go to router 4 and get it configured here. interface loopback 0, then IP address, so it's going to be all 4s, /32, subnet mask, and actually we'll just leave that like that for now. I don't even know if we need the loopback yet on router 4. Again, it's going to be running RIP. So let's go to interface FA00. We'll give it the IP address 172.16. Oops. I don't know what happened there. Let's see. Uh, 172.16. Here we're going to give it the IP of 34.4 with the /24 subnet mask. And what we're going to do is we're going to be running RIP on this router from router 4 to 3 over this 34 network. So we'll go ahead and put in here router RIP, then no auto summary. We're going to be running version 2. And we're going to be advertising network 172.16.0.0 into RIP. Okay, on router 3, let's go ahead and set up RIP as well. So we'll go router RIP, then we'll do no auto summary, and then we'll do a version 2, then we'll run it on network 172.16.0.0. Okay, so that's it so far. Now is the fun part. What we'll do first is I'm going to show you guys how to create a stub network, and we're going to be taking a look particularly at what a stub network, the OSPF area stub, what type of LSAs they will filter, and what we're going to see with the OSPF network type of stub is that LSA type 5s, which are external LSAs, or LSAs that have originated outside of the OSPF domain, are going to be filtered from entering the area. What I'll do here, what I'm thinking about doing here is doing a very simple redistribution between RIP version 2 and OSPF on router 3. That way we can bring these routes in to OSPF as being external type 2s, and then we will see the advantages of running a stub network. So we'll start this video doing that. We'll go ahead and we'll go to router 3. Router 3 is going to be where a lot of the action is at. It's going to be the ASBR because we're going to be performing redistribution on it, and I'll show you how you can verify that. So we'll just go config t router RIP. First we'll redistribute the OSPF routes in, so we'll do a redistribute OSPF, and then process ID is going to be 1, and then we'll just put in a metric of 3. That way we can see that they've actually been generated, redistributed. So and then next thing we got to do is just go under router OSPF 1, and we'll go ahead and do a redistribute RIP. And as you can see, we have a bunch of options. We can tag the routes as they come in. We can put in a route map, so we can do more advanced filtering features that we're not going to really do right now. What we're just going to do is do a redistribute RIP subnets. By default, if you just do redistribute RIP, only the classful networks will be advertised, but we want the subnet information as well. So we'll go ahead and just do a redistribute RIP subnets, Then you can also put in a metric, to add, default metric for OSPF. We're just going to leave it blank for now. So redistribute RIP subnets. And the next thing I want to do is go to router 4, and we'll advertise a couple of networks here into RIP. So let's do interface loopback 1. Let's do IP address is going to be 192.168.1.1 all /24. Then we'll do interface loopback 2. It's going to be IP address 192.168.2.1. And interface loopback 3, IP address is going to be 192.168.3.1. And interface loopback 4, which is going to be IP address of 192.168.4.1. So now, if everything is working properly from router 4 to router 10, what we should see on router 10 is these, RIP routes being redistributed via, RIP into, the OSPF domain, and, being advertised all the way through the OSPF domain all the way to router 10. So let's go to router 10 here. Again, we didn't even verify that our neighbors were up, but if we're seeing these routes on router 10, then all of our neighbor adjacencies are good throughout our OSPF domain. So if I just do a show IP route, let's see here. As you can see, we have one external route. Looks like the route between router, let's see here. What's going on? We have route, between router 3, we're seeing the 34 network being advertised. Now let's go to router 3 and see what's going on here. Let's see, we have a problem. We're not even seeing the routes coming in to router 3. So we're seeing this route coming in external 172.16.34.0, and the reason that is because when we did a redistribute RIP subnets, remember we advertised this network into RIP. So that is why we are seeing the 34 network as an OSPF external type 2 route now, is because when we did the redistribute RIP command, we redistributed this directly connected interface into RIP. However, on router 3 doesn't even look like we're seeing the actually, you know what we forgot to do? I must have I had a brain fart. I don't understand why I did not do this. I forgot to advertise the routes into RIP, the loopbacks that we created. So we'll go into RIP. We'll just do a network 192.168.1.0, 2.0, 3.0, and 4.0. So now, if we go back to router 10, if I do a show IP route, well, still don't see the routes yet. Let's give it a second to propagate through RIP. Well, I gave it about a minute to propagate, and the routes still weren't coming in. So what I did was I found here on Fast Ethernet 00 on router 4, our interface was shut down. So that's not going to help us out any. So let's go in here and just do a no shut on the port. And now we should see, and I drew this conclusion by going to router 3, and I just did a show IP protocols, and I saw under the RIP routing process, routing information sources, there were none. And if you have neighbors within RIP, it's going to give you those neighbors there. So let's just give it a second to discover the neighbor. If I do a show IP route on router 3, as you can see now, I'm seeing the routes come in. And now I'm seeing, router 4 as a routing information source. So it just took a minute there after I, unshut the port. But now you can see on router 3, we're seeing all the routes learned via RIP. I want to go to router 10 now, and if I do a show IP route, as you can see, I'm seeing these routes coming into OSPF as external type 2s. Now what we can do, if we do a show IP OSPF topology, I'm sorry, not topology, show IP OSPF database, wrong protocol, I was thinking about EIGRP. So if I do a show IP OSPF database, this is going to give me a lot of good information here. It's going to give me, as you can see, we're seeing those routes that we redistributed from RIP into OSPF. They're coming into router 10 as LSA type 5s. We're also seeing LSA type 4, which is summary AS, basically this is the ASBR router, the link ID, which is the router that's the ASBR, which is router 3, and of course our advertising router to us, which is advertising this summary, is router 1, which is the ABR in area 10. So again, our ASBR is in this case going to be router 3, and it's pretty much known as like a gateway for all external routes. So again here, type 5 external LSAs, we're seeing our external routes over here under the link ID field. We're seeing the advertised router as the ASBR. In this case again is router 3. We're seeing the summary are the the LSA type 4, which is the ASBR summary. It describes and tells us where who is the ASBR, in this case router 3 is, and our advertised router in this case is our ABR, our area border router, which is router 1. We have also, as you can see up here, we have LSA type 3s, which are summaries. Again, a LSA type 3 describes routes that are originated outside outside of this area, which is area 10. So what we're seeing is the networks outside of area 10 but are still internal to the OSPF domain. So we have the link between router 1 and 2, which is area 0, and then we have the link between 2 and 3, which is area 23. And then we're seeing here LSA type 2. LSA type 2 is produced by the originated by the designated router on the the segment. If there is a DR or BDR election, in this case there is, and the designated router is ourself here, which is router 10. And then we're seeing here LSA type 1, which is router link LSAs, and this LSA basically are produced. Every router produces LSA type 1 for its interfaces that are that it's connected to. So LSAs, again, pretty much part of the OSPF data structure, and we use them to pretty much propagate throughout the OSPF network, and to learn about other networks or other areas within the network, external links, who the autonomous system boundary router is, the ABR, and such. So what I'm going to show you here first, I'm going to now get into some of the area, different area types. What we're going to look at here first is a stub area. So what we're going to see here, by default with stub areas, if we go under an area and list it as a stub area, we're going to see that LSAs type 4 and 5, which are LSA type 4 again is the ASBR LSA, and then type 5 is the external LSA. What we're going to see when we pronounce an area a stub area is that these LSAs will be filtered, and they will not be flooded into the area. However, in this case, we'll still see LSA type 3s coming in from area 23 in this case, which are, remember, inter-area routes. So it's still within the OSPF domain, and however it's not an external route, or it's not propagated by the ASBR. So we'll go under. So we're going to go under here to router 1. Again, this is performed under the area border router. In this case, router 1 is the area border router for area 10. So we'll go under router 1 here, and we'll go ahead and do, we'll go under router OSPF 1, and then we'll go ahead and do an area, and then specified by the area here, which is 10, and then we'll pronounce it a stub. So as you can see, the OSPF neighbor adjacency is down. And what we have to remember with OSPF, in order for neighbor adjacencies to form, all routers within the area have to have the same credentials. There's a list of credentials. One of them, being the stub flag. And in this case, router 1 has the stub flag set. However, router 10 does not. So what we're going to see here is that the neighbor adjacency will never form. And what this is going to basically tell us is that we need router 10 to be set as a stub as well, and any other router within the area. So we'll go to router 10. We'll go under router OSPF 1 here, and we will do a area 10 and then stub. So we should see our adjacency come back here any second. As you can see now, we have our neighbor adjacency back with router 1. So if I go to router 10 now and just take a look at the the OSPF database by doing a show IP OSPF database, as you can see, the difference here, big difference from what we saw earlier, is that we are not receiving LSA type 4s, which are again originated by the ABR, which is router 1 in this case, in area 10, and it's just telling us, informing us of where the autonomous system boundary router or the ASBR router is. So we're not receiving LSA type 4 anymore, and we're also not seeing external LSAs, which is LSA type 5 for external routes. The other big difference is that you can see here with our LSA type 3, our summaries is that we're now seeing a default route propagated into the OSPF domain. So I can also see this default route if you just look at the routing table and do a show IP route, as you see here indicated by the OIA here. This is telling us that this route is candidate for a basically candidate default route. So again, if this router, and we all can remember what a default route's purpose is. If the router doesn't have a specific match in the routing table, last ditch effort is it's going to pretty much throw the traffic out wherever the default route is pointed. In this case, it's pointed towards Fast Ethernet 01. So what we can do here is we just need to verify that we still have reachability to our external RIP routes. We can do this if we just do a ping 192.168.1.1, and as you can see here, we are successful. So even though the routes aren't showing up in the routing table, it's not a big deal. We have declared this area, which is area 10, a stub area, and in so doing that, a default route was propagated throughout the area, and we can see that here in router 10 in our routing table. We're seeing a default route now. Also, again, to verify, just do a show IP OSPF database, and as you can see here, we are no longer receiving LSAs type 4 or 5, and we are seeing the default route LSA type 3 here coming through from the ABR, which is router 1 here. Okay, so that's a stub area. Now that we have a stub area done, what I'm going to jump into now is a totally stubby area. Now, the big difference between a stub area and a totally stubby area is that this default route that was put into the OSPF database here, the summary LSA type 3 that was propagated by the ABR, which is router 1, was going to be the only type 3 LSA that we receive within the area. All other inter-area routes in this case will be filtered from the OSPF database. Again, this is just another way to to lessen the burden on your the OSPF Link State database, and also LSAs coming into areas in which they really don't need to. As long as we know how to get to router 1, why do we really need to know about the links, the 12 and the 23 subnets? As long as we're getting a default route by the the ABR, and if we and as long as the ABR knows how to get there, then in all reality, these other routers within the area don't really need to have that information taking up processes on the CPU and utilizing unneeded bandwidth on the network. So again, it's just another way to further filter routes, and in this case we're filtering inter-area routes, or routes within the OSPF domain. However, they're not within area 10. So in this case we'll see these routes here, 12 and 23, go away. So let's go ahead on and do that here. Again, this is going to be configured on the ABR. So what we're going to see here is that router 1 does not need to be configured with the same network type. So as long as router 1 is configured for a stub network, it's going to be compatible with the ABR setting, which we're going to put as stub no summary. So we'll go here under router 1 and we'll do an area 10 stub and then follow it up with a no summary. And if we go back to router 10 here now, and we'll do a show IP OSPF database. We'll give it a second here. It looks like the age timer is pretty low. And there we have it. We have filtered all LSA type 3s except for, our default route. So at this point, again, totally stubby area is pretty simple to configure. You don't have to, specify stub, no summary, and all the other areas and all the other, and all the other routers in area 10 or whatever area you're doing a totally stubby network type or area type. You only have to do it on the ABR, which in this case is router 1. So again, if we look at router 1's database, if we do a show IP OSPF database, you can see here router 1 still has all the LSA types 1, 2, 3. Again, it's an ABR, so we're seeing LSA types for both area 10 and area 0. As long as router 1 knows how to get to all these other networks via OSPF, there's really no need for the routers behind the ABR, in this case router 10, to know of these other paths. So we can filter them using different area types. In this case, we already just did the areas, the stub area, and we just did the totally stub area. So okay, so let's go ahead and finish this video off. We're going to go ahead and do the last two OSPF network, area types here. We're going to do a not so stubby area and a totally not so stubby area. What we're going to do to be able to see the full effects of this in area 10 is what I'm going to do. I'm going to go to router 10 here and do a router OSPF 1 and do a no area 10 stub. And on router 1, we'll go ahead and do a no area 10 stub, no summary. So we're going to go ahead and blank this back to the default. What we should see here on router 10 is external type 2 routes coming in. If I do a show IP route on router 10, we'll just give it a second. The LSAs and the Link State databases and all that other stuff, database descriptor, all that stuff has to reconverge here. So we'll give it a little time. See if I got my neighbor adjacency up. Show IP OSPF neighbor from router 10 to router 1. Let's clear the process, kind of speed things up here. And what we're going to see here with a not so stubby area is that it's very similar to a stub area, where it's going to filter type LSA type 4s and 5s. However, the big difference between a stub and stub and a not so stubby area is that on an NSSA we can actually perform redistribution and allow what's called 7 to 5 conversion. So we're actually going to introduce our redistributed routes as type 7 LSAs and propagate them through to the rest of the network as a type 5 LSA. So it gives us the advantage of performing redistribution. However, no LSA Type 5s can come into the network. So in this case, if we were to go to, router 10 and configure some redistribution, to have some external routes coming in router 10 through maybe like EIGRP process over here, and we make router 2 area not so stubby area along with router 3, what we're going to see is these external type 5 routes will not be able to come back into area 23. So you have to be careful on where you place your not so stubby areas and your stub areas, of course. But in this case, what we're going to do on router 3 is we're going to make it the autonomous system boundary router, as it already is. If we can see this too, if we go to router 3 and do a show, I think we just need to do a show IP protocols here. Show IP protocols, look under OSPF. You can see here this router is an autonomous system boundary router. That's because we are performing redistribution and we're running OSPF. Okay, so let's go back to router 10, just make sure we have the old everything back into place here on router 10. If I do a show IP route, still nothing. You know what it is? And this is a good point to bring up here. When you have the area, like if you have a totally stubby area configured, and you go into your configuration and you do no, in this case, no area 10 stub, no summary, it's not going to take the whole command off of there. All it's going to take is the no summary part off. So you're actually still going to have the area 10 stub command in your router. So it's still going to try to act like a stub router, but not a totally stubby area. So let's go to router 1 and I'll actually show you this here. If we go to router 1's configuration and do a show run pipe to begin OSPF here. On router 1, what we'll see here is we still see the area 10 stub command. Even though I did the no area 10 stub no summary, that just backs off the no summary, and then you're still left with the stub. So if you're seeing problems with OSPF converging, or your adjacencies coming up, just go back in here and make sure that you don't have this in. So we're going to go into router 1 here and do a get rid of this command here. So we'll do no area 10 stub, and now what we should see is our neighbor adjacency should come up between router 1 and 10, and then what we should see on router 10 is we should see all of our routes back here. So on router 10, if I do a show IP route, as you can see, I'm seeing the external routes coming in from router 4, I believe. So let's do the ping real fast, 192.168.3.1, and we have connectivity. We see the external routes coming in on router, let's see, router 10 it is. So what we're going to do is, okay, so let's go ahead and go back here into, we're going to make area 23 a not so stubby area, and we're going to do this by going on to router 2 and configuring it for area NSSA. And we're going to take a look here at some of the the differences here between a not so stubby area and a stub area. So let's go to router 2. Actually, let's go to router 3 first, and we'll do perform the NSSA on router 3 here. So again, it's just area, and then you'll see here area 23 is what we're going to be doing here, and then you'll see here NSSA. So we'll go ahead and hit enter there for router 3. As you can see, the neighbor adjacency with router 2 went down. Again, it's the same thing with the stub area. The stub flag has to be set, and as you can see between router 3 and 2, that is not happening. Router 3 has it set, but router 2 does not. So we'll go to router 2 here, and we'll go under OSPF, router OSPF 1, and we'll do a area again here 23, and then we'll do a not so stubby area, or NSSA. Go ahead and hit enter there. Then what we're going to see is the neighbor adjacency will be coming up here shortly between router 2 and 3. And then we'll go ahead and take a look at our OSPF database throughout our OSPF domain and just see if there's any differences here. Let's just look on router 3. If we do a show IP OSPF database on router 3, as you can see here now, we're seeing type 7 LSAs. Again, these are for networks that are originated outside of the OSPF domain. They're coming in to the not so stubby area. In this case is area 23, and we're listing them as type 7 LSAs, and we should be sending them out to the rest of the OSPF network, area 0, and area 10 as LSA type 5 external. So again, the main difference here between a stub and a not so stubby area is that a NSSA will allow you to perform redistribution, and let's go to router 10 and let's just see a little difference here in what's going on in its OSPF database. So again, as you can see here, router 3, we're seeing type 7 LSAs being generated. So inside the NSSA network, which is area 23, we're going to see type 7 LSAs. So let's go to another network here. Let's go to first we'll go to router 2, which is in area 0, and we'll do a show IP OSPF database. As you can see here, we're seeing the conversion from 7 to 5. You can see type 7 LSAs, which we're seeing generated by the autonomous system boundary router, which is router 3, and then we are seeing the conversion here between the 7 to 5. So router 2 is actually taking those type 7 LSAs and converting them to type 5 LSAs. As seen here, and it's advertising them, it's giving itself as the advertising router here. So it is the area border router. So if I go to router 1 and look here and see if it's going through area 0, these routes show IP OSPF database on router 1. You can see that I am now seeing strictly type 5 LSAs. I'm not seeing type 7 LSAs anymore. So again, not so stubby areas taking redistributed routes. In this case, we redistributed RIP routes into OSPF. It's taking those LSAs and converting them from type 7s. So the area will allow those routes to traverse, and then when it hits the AVR is converting them to type 5s and then sending them on here. So as you can see in area 0, we're now seeing those routes as type 5s and not type 7s. So if I go to router 10 and look at its database, again, it's strictly in area 10. So if I do a show IP OSPF database here, as you can see, we are seeing all of the routes advertised as type 5s, like before. Now at this point it's very critical to point out that with the not so stubby area, we are not seeing the generation of a default route like we were in a stub area. So it's very important to remember that if you're using a not so stubby area, when you do that, you have to remember that within your OSPF domain there will not be a default route generated throughout your domain, kind of like when you configure a stub area, you're getting a default route generated. With not so stubby area, you are not going to see a default route propagated like we're seeing here. We're just seeing the type 5 external LSAs. We're not seeing a default route coming in. We're still seeing LSA type 4, so we're seeing here LSA 5, LSA 4. We're seeing summaries for the different networks outside of the this area, so those are summary LSA type 3. We're seeing network links, the designated router pretty much is LSA type 2, and then we're seeing the router links here, so LSA type 1. So let's go over the last area type here, and then we'll just wrap it up now. The last area type is that we're going to see is a not so stubby area, or not so stubby, totally stubby area. So again, actually one thing I want to point out here is that you're seeing, you're still seeing LSA type 4s and type 5s. Okay, but that's in a different area. This is area 10. If we went back to router 2 here and looked at the area in which we did the not so stubby area, where we put that in, which is in area 23, as you can see, we're not seeing, let's just do a show IP OSPF database here again. As you can see, we're not seeing in area 23, we're not seeing LSA type 4s or 5s. Again, we're just seeing type 3, which are summary netlinks advertised by the ABR, which is router 2, which is this router, and we're also seeing type 7 LSAs, and then we're seeing the conversion from 7 to 5. So again, let's go to router 3, and we'll go ahead and set up the totally not so stubby area. So again here, let's just take a look at the background at our topology here. We have, router 3 is the ASBR. Probably should have put this on here a long time ago, but router 3 is the ASBR because it's doing, again, we're bringing those routes in, we're redistributing the RIP routes into OSPF. So it's going to be the autonomous system boundary router. Basically, the ASBR is the route out to the how you get out to the external link, external networks. Router 2 is the ABR for area 23. Go put here ABR, and router 1 is the area border router, or ABR, for area 10 here. So last thing here, let's just go to router 3, and we'll go to router 3 again, kind of like the totally stubby areas where we only have to put the stub, no summary under the ABR, under the ASBR in not so stubby area. That's all we have to put it under there. So let's go ahead and do this under router 3. Router OSPF 1, and then we'll do area 23 NSSA, no summary here. Again, before we do this, let's go to the routing table on router 10 and take a look. If I do a show IP routes, what you're going to see here is I'm seeing all the external, type 2 routes coming in from router 3 and the redistribution that we did from, RIP version 2 to OSPF and vice versa. I'm going to go ahead and put this command in here on router 3, area 23, NSSA, no summary. And if I go back to router 10 now, which is in area 10, on the very other side, the other end of this OSPF domain, if I do a show IP OSPF database, let's give it a second here. Let's go to router 2, and we'll just do a clear IP OSPF process. Yes. And we'll give it a second here to for the OSPF network to converge. Okay, and I just gave the OSPF network time to converge. It doesn't look like anything's happening, and I'm going to tell you exactly why here, because I actually put the area NSSA no summary command on the wrong router. I actually put it on the internal router instead, the router where I did my redistribution. Actually, it doesn't belong on there. It actually belongs not on the ASBR but on the ABR in the area. So in this case, the ABR for area 23 is router 2. So what I'm going to do is go to router 3 here, and what I'll put here on router 3 is actually I was right where I needed to be, don't know why I got out of there. I'll just do a no area 23 NSSA no summary. Again, needs to be done on the area border router, not the autonomous system boundary router in the area. So in this case, the area border router is router 2. So let's go to router 2 here and get this done here. So router OSPF 1, area 23 NSSA, and then no summary. Okay, so once that's configured, again, what we should see with the totally not so stubby area is that the ABR is making, the pretty much a totally stubby area, But the only difference, again, really, with the NSSA, the totally NSSA, and pretty much, these networks is that the NSSA, takes away type 4s and 5s, where the totally NSSA is going to take away the inter-area routes as well, which is type 3 LSAs. What we also should see here is that a default route is propagated throughout the network, not like what we saw with the not so stubby area. That was not the case. Let's go now to back to router 10 and see what we can see here in the OSPF database and in the routing table here. So if I do a show IP route on router 10, I'm still not seeing the external route. Let's do a show IP OSPF database. Still nothing here. Let's see here. Again, router 2 is the ABR for area 23, in which we are, we have configured as a not so stubby area. So let's go to router 3 and see what we have going on here. As you can see, area 23 we listed as a not so stubby area. So everything looks fine here. Let me just go back to router 10 and take a look. Okay, you know what it is? Looks like here all the summary routes, the LSA type 3s, are gone within area 23. So what we're seeing in this scenario is that we are seeing the default route now being advertised into the area. And this default route, if we do a show IP route on router 2, we are seeing all the ON2 routes here. Again, this is OSPF NSSA external type 2s. And as you can see here, all the inter-area routes within the OSPF database have been removed. Now if I go to router 3 and take a look here, if I do a show IP route, what we're seeing now in router 3 is the default route being propagated throughout the OSPF network. So again, router 2, we configured it with the area 23 NSSA no summary command. In so doing that, when we look on router 3 and do a show IP OSPF database, we can see that there is no longer any summary LSA type 3 you know, addresses listed here except for the default route. And again, before, you know, when we did this, you know, when we did just you know, a not so stubby area, we saw only we saw summary routes, but we did not see the default route being propagated throughout the network. So now if we do a show IP route on router 3, you can see that the area now has a default route propagated to it right here. So all the other OSPF, you know, learned routes, you know, from all the other routers are all gone. All it has is a default route. If I try to ping, you know, router 10, which is what, 172.16.10.10, as you can see, I still have full reachability all the way throughout the network. The only difference here is that the not so stubby, totally stubby area here has you know, generated a default route. And so instead of having all the OSPF networks listed here in my routing table, I just have one simple default route propagated into the not so stubby, totally stubby area here. Again, if I take this command off of here on router 2, if I just go back into my router OSPF 1 configuration and do a no area 23 not so stubby area, no summary. If I go back to router 3, I can see the changes here. If I do a show IP route, you can see these inter-area routes, which are learned via LSA type 3s. Again, this is, you know, area 0 between, you know, router 1 and 2, and then this is area 10 between router 10 and 1. Also, if I do a show IP OSPF database on router 3, what we're seeing here is we're able to actually see you know, summaries, which are, you know, LSA type 3s here. So we're seeing those summary routes, the 10 and the 12. We're also seeing those in the routing table, 10 and 12 here. And again, the big difference with the not so stubby area and the not so stubby, totally stubby, besides the deletion of the LSA type 3s, is that there is not a default route propagated, as you can see here with the summary. Before, like with the stub area, we saw the summaries, you know, we saw the link IDs of, you know, the inter-area routes, and we saw a default route. However, with the not so stubby area, we're not seeing a default route being propagated. We're only seeing you know, the network links here, the LSA type 3s. So if I do a show IP route, as you can see, we're not going to see a default route. And so that's pretty much it, guys. That is a crash course on, you know, the OSPF area types. I hope you guys, you know, got a lot out of this video. Excuse me. There's a lot to take in, so if you have to go back and watch it again, write down notes, or just, you know, go in and you know, configure the network too as well, and, you know, get some hands-on experience. I think that's a great idea to do. Again, thanks for watching the video with me, and I hope you'll be with me with the next one. Thanks.